go do another one of those mathlete.org geometry problems, and whoa, that is a lot of subscripts. Who keeps writing all these problems anyway? Time to figure out what this all means. Okay, points a, x sub 1, and y sub 1 are marked on the plane such that a x sub 1 equals 5, a y sub 1 equals 12, and x sub 1, y sub 1 equals 13. Oh, that's a 5, 12, 13 right triangle. I'm going to go draw that right there, and I'm going to go label the points for convenience sake. Then 5, 12, 13. Okay, that shouldn't be that bad. For integers, 2 is less than or equal to I is less than or equal to 100. Point x sub I is on line a x sub 1 such that x sub 1 is between a and x sub I. A x sub I is greater than a x sub I minus 1, and a x sub 1 is equal to x sub I minus 1 x sub I, and ditto for y. Okay, time to figure out what all this means. That line part is going to be pretty useful. And same thing with the ax sub 1 is equal to x sub I minus 1 x sub I. I think this means that all these points are going to be equidistant from each other, spaced out kind of like that. So I think we can figure out that this is going to be x sub 2, and then x sub 3, and then x sub 4. Oh, and we are already out of room. And we're going to have to do 100 of these points. No way we can regionally fit them all in a single diagram. That is going to be a big challenge of solving this problem. After drawing all the first 4 points, okay, I'm going to go move on and see if there's any pattern I can exploit. Okay. Additionally, for odd integers, 1 is less than or equal to j is less than or equal to 99. The region x sub j, y sub j, y sub j plus 1, x sub j plus 1 is shaded, and the rest of the regions are unshaded. Okay. 1 is an odd integer, so x sub 1, y sub 1, y sub 2, x sub 2 is going to be shaded. Oh, I already saw that in the diagram. I'm going to go draw that real quick. And after doing this, okay. 3 is also an odd integer, so x sub 3, y sub 3, y sub 4, x sub 4 also going to be shaded. Okay. I think I'm already seeing a pattern with the shading and stuff. Okay. Looks like those strips are going to be all shaded, and they're going to be alternating. So it's going to look like something like this, where you're going to have alternating shaded strips and unshaded strips. But that's a lot of strips that we need to calculate the area. I mean, the instructions say to compute the area of the shaded regions, but that's a lot of shaded regions we need to calculate. These are all trapezoids. Yeah, you can prove this after using your SAS similarity and parallelogram things. But now we need to find the 2 bases and then the height. That's a lot of calculations that we need to worry about. I wonder if there's another way to think about the area. Okay, I'm going to go think big picture and make this totally not to scale diagram with a and then x sub 100 and y sub 100. And then I'm going to go consider x sub 99 and y sub 99. Okay. In that case, I have noticed something. A, x sub 100, y sub 100 take the area. And if you subtract the area from a, x sub 99, y sub 99, you get the area of x sub 99, y sub 99, y sub 100, x sub 100. And that's going to be pretty useful. Another thing you notice is that's because of the equidistant thing, I can find a x sub 100 from 100 of those 5 side lengths all put together. You know what that means? I think there's a way we can figure out the area. And yeah, there's patterns I can make use of. So I'm going to go do some calculations right now and see what result we come up with. Okay, so the result I ended up getting was 500 times 1,200 divided by 2, and then minus 495 times 1,188 over 2, and then add 490 times 1,176 over 2, rinse and repeat. And then in the last few stuff, you get 10 times 24 over 2 minus 5 times 12 over 2. But that is a lot of calculations. Sprint has a time limit, and I'm going to need to find a more efficient way to do all this calculations. But considering how we got all these calculations from the 5, 12, 13, and then you're scaling it up, I think we can factor the 5 times 12 over 2 out. I'm going to go do that, and then we're going to see that it is 100 squared minus 99 squared plus 98 squared minus 97 squared all the way to 2 squared minus 1 squared. Oh, difference of squares, how convenient. 100 squared minus 99 squared equals 100 plus 99 times 100 minus 99. 100 minus 99 is going to be 1. Oh, that's convenient. And then I get the result 5 times 12 or 2 times 100 plus 99 plus 98 all the way up to plus 1. And at this point, I think the coast is clear. The calculations are a lot more manageable. I can use my arithmetic series formula, and then I get the answer of 5 times 12 over 2 times 101 times 100 over 2. Do all that, and then I got the answer of 15, 15, 0, 0. Oh, that happens to be answer choice D.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.